Have you ever imagined how different flowering plants has different flowering seasons? How does this plant experience the seasonal changes? How does this plant senses that there is a change in signal? One of the factors how this sense is detected is by photoperiodism. Hello friends, my name is Arpita and in this video we would analyze the concept of photoperiodism. We all know that light is a very important factor or rather a very important source of energy for plant for conducting their various pathways. Where photoperiodism is basically a physiological reaction of an organism in response to the length of day or night. The plant responses controlled by daylight are numerous, including the initiation of flowering, asexual reproduction, formation of storage and storage organs, and onset of dormancy. This light mediated growth and development in plant is referred to as photomorphogenesis. Let's break it down. Photo or photon means light. Morpho means morpho is indicating some form or structure. Genesis means building up or synthesis or making something. So the formation of a structure in response, formation of a structure, some kind of growth in response to the presence of light could be referred to as photomorphogenesis. However, the day length alone is a very ambiguous signal because one cannot distinguish between the day length in spring and in falls. So, this ambiguous signal must be coupled up with certain other such adaptations so that it gets a prominent signal. One such adaptation is temperature. So, based on this, plant can be differentiated into two broad classifications. One, long day plants. Second, the short day plants. Let's see. So, long day plants flowers when the day exceeds or the night length is less than a certain critical duration in a 24 hours cycle. Now, short day plant flowers when the day length is less than a certain critical duration in a 24-hour cycle. Now, let's analyze this graph. Here in the y-axis, here in the x-axis, we have day length and night length. And here in the y-axis, we have percentage flowering. So let's at first talk about the short day plant. In this short day plant, as you could see, that more is its exposure to the night length, more is the percentage of flowering. 18 hours, 16 hours, 14 hours, 12 hours, we could see that the percentage of flowering is always 100%. But after a certain period of time, when the night length is not sufficiently long, the percentage of flowering got decreased to 0%. Similarly, when if let's analyze the long day plant. In this long day plant, the exposure to short daylight, as we could see, for 6, 8, 10, 12 hours, the the percentage of flowering is 0. But when it exceeds certain critical duration of daylight exposure, it is reaching its 100% of flowering. That is, to a longer exposure of day like 14, 16, 18, 20, 22, 24 hours of exposure to the daylight, it is exhibiting a high concentration or a high percentage of flowering. Let's clear the concept a little bit more. So this is a short day plant. This is for the long day plant. This is the critical certain critical duration. Okay. So If the plant is exposed to a longer period of day as compared to the night, we could see that for short day plant, it is in its vegetative form and it's not flowering. When it is exposed to a longer period of night as compared to the day, then the plant is flowering. Now here, the plant is exposed to a shorter period of day as compared to that of the night, or as compared to that of the dark, but there is an exception in between these two. What is it? This is the flash of light that is given in a continuous phase of dark. This is called the night break. So night break is basically a flash of light, or a light given in a continuous uh, during a continuous period of dark phase. So in this case, the plant is not flowering and it is in a vegetative form. A possible reason behind this could be the phytochromes. Phytochrome are basically some photoreceptors that are present in the plants. It absorbs light at red and far red region. When the light during the daytime, when the light strikes the leaves, the photoreceptors, the photoreceptor phytochrome gets converted from its PR to its PFR form. So phytochromes has two forms, PR and PFR. PR here means red and FR means far red. So when light gets exposed to the sunlight, the PFR gets converted into, sorry, PR gets converted into PFR, and this conversion is fast. However, during night time, the PFR gets converted into PR, and this is a slow process. This decaying process of PFR is a slow process, and this PFR has different mode of actions in different plants. For example, for short day plant, the PFR has inhibitory effect. That is, if the concentration of PFR is more than the desired for the short day plant, this plant will be in a vegetative mode and it will not flower. So PFR is inhibitory to the short day plants for flowering. However, it has an activating effect for a long day plant. So let's go back to the to this diagram again. So one possible reason behind this could be, since the conversion from the PFR to PR is slow, a short flash of light in a dark phase resulted into the change of the PR into PFR. Since the reaction is fast, the PFR got accumulated. Okay, and as a result of which, it is exhibiting an inhibitory effect. So this could be one of the reasons why why this short day plant is not flowering, even though it is having a night exposure, because of this um, night break. Now let's analyze. Sorry. Now let's analyze this long day plant. In this long day plant, uh, you could see this day, the time period is more than that of this certain critical duration. So the daytime it is exposed to, it's long enough, so that's the reason why it is flowering. It is a short time, it is having a short day exposure, so it's not flowering. Here it is having a short day exposure even though it is flowering. The reason behind it is this night break. As you could see, the exposure to the night break resulted into an increased concentration of PFR, and this PFR is having an activating effect to the long day plant. So this resulted into the flowering of the long day plant. Here in this graphical representation, we are trying to figure out that at which point should we give the night break in order for the long day plant to be more flower, to give more flowers. Or you could say it like this, that we are trying to see that at which point should we give the night break where it has its maximum effect. After an 8 hours of light period, the plant is exposed to 16 hours of dark period with a night break given at an interval of 2 hours, another experiment where it's given at 4 hours, another experiment at 6 hours, and so on. So we have observed that at the 8th hour, when the night break is given, the effect of the night break is maximum. It's a percentage of the maximum flowering in the short day plant is least and the long day plant is most. So from here, from this experiment, we could analyze the fact that not only the night break but also the point at which the night break is given is also an important factor to be considered in an experiment. So that was all for this video. Thank you.